I must say I'm really not part of Pachita. And when I saw the first sessions, I was really surprised that, wow, this is technology assessment. We had to do with impact assessment. There are similarities, but there are also some differences. And I feel like a bit odd somehow speaking in front of you now. Maybe it's something different, something completely different. Okay, it's about soil. It's about sustainable soil functions. And we thought all the stakeholders involved in soil management, they do have different ideas about how to manage soils. And we try to work out just our thoughts about what these stakeholders really think. And then I would like to show you two methods how we measured, how we approached the impacts of soil management. So, first of all, I'll introduce some of the lay persons here into soil threats, soil functions, and how we can relate them to sustainable development goals. I'll talk about the interest of stakeholders. I'll talk about two examples of impact assessment, not technology assessment, and I'll draw some conclusions. So here they are, the soil threats. The EU Commission had commanded or had put up a soil thematic strategy in 2006, and during this process, certain soil threats were shaped or were found out. First of all, it's erosion, it's soil contamination, it's compactions through heavy machinery running over soils, it's salinization through irrigation processes, soil sealing, as we all know, too many buildings, too many streets are put up, so soil sealing is a threat. There's a decline in organic matter. That's also an important issue in European soils because organic matter improves soil fertility. And there's a loss in soil biodiversity due to pesticide application. So, how does this relate to soil functions? Later on, the EU and scientists thought only talking about soil threats is not enough. We have to also show that soils are not just endangered, they do have certain functions. So therefore, a list of soil functions was elaborated. And first of all, as we all know, soils are used to produce food and other biomass, but soils also have other functions. It's about storing, filtering, transformation. Soils are habitat and a gene pool. Soils are physical and cultural environment. They're a source of raw material. Soils are used for producing. Soils are now even more considered as a carbon pool. So through certain practices, you can store, you can sequester carbon into soils. They are considered a geological and archaeological archive. And what's not on the official list, but what's becoming more and more important is soils are also becoming an object of speculation. I just say it as in terms of land grabbing, for example. So there has been a shift now from these threats that I mentioned towards the functions. And each threat can be related to functions. So there are links between each other. So why do we actually need proper soil functions? So I relate this to the Sustainable Development Goals. So you all know the Millennium Development Goals, but the UN is already moving forward. In 2015, the Millennium Development Goals should be all achieved. Maybe they are not, but they are working now to a more universal way of looking at these development goals. The Millennium Development Goals had been very focused on, say, the developing countries. So now we put it more into a global perspective. And so why do we need proper soil functions? First of all, goal 2, we want to end hunger, achieve food security. improve nutrition, promote sustainable agriculture. So there, soils play a very important role. I also mentioned the other ones, ensure sustainable consumption, and goal 15, where we really are into the ecosystem services that soils can provide. So let's look at the stakeholders involved in soil conservation. There are, for sure, the farmers. There's civil society that gets more and more aware of how important soils are. The policymakers, the planners, and the researchers. Maybe this list is not complete, but these are the ones that we had in mind, first of all. So the farmers, what are their roles? What are their responsibilities? So first of all, a farmer needs soils, needs their land as a production asset. They have to produce, and they need proper soils. And they do have an interest in preserving this, its functions over a certain time span. But this time span, it's argued in literature, this time span that a farmer looks at might be shorter than that of society. So we come to that later. So society, or civil society, is an important stakeholder in the management of soils by raising pressure on political decisions. So it's not just the farmers who are deciding, but it's also civil society who puts a weight against only this production function. They hopefully create a demand for more soil-friendly production practices. And society should wish and does wish to preserve more than just the production function of soils, but a wider scope towards all soil functions. Just back to economics, society's goal or society's view on soil function is that it is affected by the off-site impacts. So when you produce on soil, farmers have using soils, they might create off-site impacts. It can be just the runoff of soil, or it can be by reducing the filtering function of soils. So these are considered off-site impacts. And these are threats to the long-term food security. So just to put that in perspective. And society also is interested in the economic term of existence value of soils. So the policymakers, in our view, they need to balance two things. Here we come to political economics. First of all, it's their personal interest to stay in power. So they have to make good decisions to stay in power. But at the same time, they have a responsibility to find a sustainable pathway for soil conservation. Then we have the planners. In Germany, they play a quite big role. So how can we manage our scarce land and put it into an optimal way so that it's properly managed? Have farmland, have land for settlement, have land for mining, and so on. And they do have a pretty big role in the implementation. So they are involved in the political process of how to shape all these legal ways when soils are managed. So now the researchers, our community, what should we do? We should provide the evidence for the stakeholders' decisions. There is the big similarity to the technology assessment. So what's actually happening when we do something? And they should provide a deeper understanding of the different interests. So there's the social science part of it, to describe the interest, to describe the relationships between stakeholders, and to also, on the technical side, on the science, natural science side of it, to explain the causal chains. If I do something to the soil, this will happen afterwards. Okay, so now, what is impact assessment? impact assessment is considered, in our words, in our opinion, a means to structure this process, to structure this analysis of these causal chain relationships between the soil management decisions and the soil functions. So how can it help the stakeholders? So now I would like to show you two examples, maybe two very extreme examples. I'll go from a very participatory approach to a very desktop-oriented approach, and I'll draw some conclusions afterwards through it. So this approach, the framework of participatory impact assessment, was developed in an EU project. They wanted to develop impact assessment methods. The project focused a lot on modeling, but this one was a little side project that tried to develop a participatory approach. And later on, this approach should be also used in developing countries or in countries outside of Europe. So we applied it in the case study in Tunisia, where it was on soil and water conservation policies in a watershed in southern Tunisia. So the policy goals in this project that we accompanied was to protect arable lands in Tunisia, in southern Tunisia, against erosion, to control water flux, to increase land utilization, to bring more land into production, through the construction of water harvesting facilities. So it's basically you're trying to hold back water on your land. You're building up either terraces, you build up dams, or some kind of smaller stone walls. All different kinds of water harvesting technologies. So how does this framework work? So basically, it all turns around stakeholder participation. You first study, you look at the scenarios. So first you look at the policies they want to implement, and you develop scenarios with these policies. So in that case, it was, so what do you actually want to do in your watershed? There were different options, how deeply you implement these policies of water harvesting technologies. Then you look at criteria, how you want to evaluate these policies. Then you do an actual impact assessment. You check how far you can accept these impacts. And you go through this process. I don't want to go too far into details. And then you present these results to the end user. And I would just like to say, so the refining of scenarios is more or less done by the researchers. This is still away from the stakeholders. And then we slowly approach the stakeholders, double check were our scenarios right. And then all this, the rest of it is done in a workshop. You're sitting together with the experts and the stakeholders until you present the results. Then you write a nice report about it and present it back to the end user, who's the policymaker. So who should be part of a workshop like that? So each participant should have a strong background, knowledge about the regional land use and this soil and water conservation policy. And altogether, the group should be nicely balanced to reflect all the interests that are on this kind of land use. So in our case, there were 6 experts plus researchers, but these are the actual stakeholders from regional administration, development offices, agriculture and fishing organization, and the Ministry of Environment and Sustainable Development. And the special and the tricky thing about this approach is that you ask them to develop indicators that are used to describe the effect of each policy. So we sat together and tried to find 3 indicators for each dimension of sustainability. So the first 3 are on the social sustainability. The second is on the economic dimension of sustainability, and the third group is on the environmental dimension. So these were discussed, agreed on, and then we moved on. The scenarios we discussed were 3 levels of implementation in terms of percentage covered of the area by this program. So 70% is the kind of the baseline scenario. If they continue like that, they will reach 70%. And the stakeholders were saying, let's play a bit with, if we put more pressure, put more budget into it, we might get up to 100%. So that's why we had a 85% and 100% scenario. So the stakeholders we were sitting together. We gave each of these dimensions a certain score between 0, 3 and +3. And then we see that depending on how far we forced them, these policies to go, they came up with evaluations. These are means of the impact assessment. And afterwards, we looked at the results and then had an idea of, okay, if we follow a certain policy, it might be very good for, say, the green was, if you go for 100% of implementation of this policy, it's maybe good for the local employment rate, but it might be very bad for the ecological processes. So it's just a screenshot of how we can do this kind of impact assessment. And now we come to another way of doing it. It's bioeconomic modeling. So bioeconomic modeling, I don't know how far you're into that into that approach. It's basically an optimization of a real farm or virtual farm, of a regional farm, and you're linking farm data, real farm data, to, in our case, erosion risk. So whatever a farmer does, it might increase or decrease the risk of erosion. And in our case, it was a farm or regional farm in the northeast of Berlin. This farm was optimized. We all say, okay, this is a farmer, he tries to optimize, increase his profit. But we were kind of bugging this virtual farmer with policies. And I'll show you later the results. So the objective functions, as we call it, is to maximize its gross margin, basically its profit, the money it makes, but under different policy scenarios. And the scenarios we confronted this farm with were targeted or untargeted incentives for some soil conservation practices, or kind of if you compared it, carrot and the stick was row crop restrictions. So it was, the farmer was not allowed to grow anything with a high erosion risk on slopes. So those two policies we compared. This might be going too far. Just we assessed the site-specific risk. So it's a hilly region. Certain areas have a high risk of erosion. Other areas don't have a high risk of erosion. We assess the production practices. So say if he grows corn silage with big row distances, there's a high risk of erosion. If he grows wheat, it's all nicely covered, has a low risk. And so we evaluate the possible combinations. So high risk on high risk land versus low risk production practice on low risk land. I don't know, yeah, it shows. So one outcome was, after this modeling, so on the left side you see if a farmer can do whatever he wants, just follows what he has to do according to the Common Agricultural Policy regulations, it shows an erosion map like that. There are some darker spots on the left side with high erosion hotspots. And then on the right side, this is a result. It's the same farmer, but now he's given incentives for certain practices. He's using reduced tillage, and he gets a certain subsidy for it. So you see, there's still some hot spots that couldn't be avoided, but you see the erosion risk goes down. So that was our impact assessment of certain policies in our little experiment bubble. And since it's an economic model, we can also have a look at the budget costs. So how much would the government have to pay for him if the government hands out incentives? We can also see how much the farmer has to adapt. So those are the green columns, the on-farm costs. And if you look at the last column, if you just tell them don't do something on slopes, the farmer can still adjust. It has very low adaptation costs, and you don't have budget costs. So those are informations you can then carry over to the policymakers. So let's compare together these two methods. The participatory approach had rather quick results. We had to do our homework first, but when we sit together with the stakeholders, basically things were done in 2 days. We had some slides, we had some results. We could actually face policymakers and say, this is the outcome of policy A, B, or C. Whereas the bioeconomic modeling is a long process. Sometimes we called it, you get the results after everything is done, after the decisions are made. So it takes time to get the model running, to adjust and get the data and so on. The participatory approach is more or less inclusive for most of the stakeholders. You can bring the farmers in, depending on how much time and resources you have. Everybody can participate, and everybody who wants to participate. Whereas the bioeconomic modeling approach, it's creating a kind of expert language that needs to be translated to become valuable again for the stakeholders. While the participatory approach, whenever we sat together and you have some real scientists in there, they always argue the validity of these results is questioned. It's questionable. Whereas the bioeconomic modeling approach, you put in real data on economics, on data you got from soil science, so it's real science. And you always have to argue between these two extremes. The participatory approach is easy to adapt. We did the same framework we used in different countries on different problems. You just have to get into the new problem, and then you can run a workshop. While the bioeconomic modeling approach is rather data intensive. You always need the new data. You have to feed your model, so it's rather difficult. It's obvious the participatory approach is rather qualitative, whereas the bioeconomic is quantitative. And the two main differences I find are here on the bottom. One is communication focused. You're sitting together and you talk, while the other one provides information. It's information focused. And that's why I find this last thought quite important. Combining both approaches might be actually the best, because it feeds the needs of all the stakeholders. Some want data, some want discussions, and I think we need both information and communication. So I'll come to my conclusions. So impact assessment can be done on different levels of stakeholder involvement. You can do it either at your desk and only walk out sometimes and ask the reality whether things are right, whether they can agree on it or not, or you do it right away together with the stakeholders. The participatory impact assessment brought a high involvement of the stakeholders with questionable results sometimes. At least that's what the scientists tell us. The bioeconomic modeling has important numbers. I should have put them in little ticks, but important numbers, but often too late. There are trade-offs between soil functions, as we try to show. On the one hand, you want food production, but on the other hand, maybe you're kind of decreasing at the same time the sustainability of your production. But these trade-offs become visible and can be debated within these workshops or afterwards. An ex-ante assessment can provide an anticipation of possible impacts. So if you are able to forecast certain scenarios, you can also discuss different management options. And my last thought is the final decision remains a political process, so that cannot be overdone. Okay, thanks a lot for listening. Okay. Hey.
We can have 1-2 questions.
Yeah?
You looked at antibiotics usage in soil?
Not in these case studies.
Generally?
No, not yet.
That would be a really interesting field of application for your model because it has a lot of off-site effects in the medical system.
Yeah.
And the farmers, to my knowledge, are extensively spraying antibiotics, especially on fruits.
Yeah.
And it's a huge problem, and it's not even known to the stakeholders that it is a problem.
Okay. Yeah.
They're ignoring the fact that they have some responsibility if they use these kind of substances.
Yeah. Okay. Thanks for that. Yeah.
In your participatory approach, did you face a problem with attracting certain groups of stakeholders to the television?
That was part of our local researchers there, and they had a good network of people who are working in this watershed already for a long time. I mean, that's one lesson I really learned with always working on soil conservation now is if the problem is big enough, you will always find interested stakeholders. So there, it's no problem. You could ask anybody and they would say, yes, we will join you. Whereas the case study I showed in Germany, you had to really push the farmers to join you. And we discussed that a lot. If you do this thing, for example, in Australia, where erosion was a problem, no problem to find stakeholders. It's really, one thing is, maybe the soil scientists know there is a erosion problem, but as long as it's not really hurting the farmers, it's not really perceived as a big problem.